This test measures your ability to understand conversations and lectures in English. You will listen to 3 lectures and 2 conversations. You will hear each conversation or lecture only one time. After each conversation or lecture, you will answer some questions about it. The questions typically ask about the main idea and supporting details. Some questions ask about a speaker's purpose or attitude. Answer the questions based on what is stated or implied by the speakers. You may take notes while you listen. You may use your notes to help you answer the questions. Your notes will not be scored. If you need to change the volume while you listen, click on the volume icon at the top of screen. In some questions, you will see this icon. This means that you will hear, but not see, part of the question. You must answer each question. After you answer, click on Next, then click on OK to confirm your answer, and go on to the next question. After you click on OK, you cannot return to previous questions.
Listen to a conversation between a student and a professor.
Excuse me, can I help you? You look a little lost.
Yeah, I am. This is my first day on campus, and I don't know where anything is.
Can't find your orientation session?
Uh-huh. What a way to begin. Lost going to orientation.
Well, my guess is it's in the auditorium. That's where they usually are.
You're right, the general ones. I went to one of those sessions earlier today, but now I need the one for my major, engineering. My schedule says the meeting room is in Johnson Hall, in the engineering department, which should be right here in front of us, according to the map. But this building's called the Morgan Hall.
Well, your map reading skills are fine, actually. This used to be Johnson Hall, all right. Trouble is they changed the name to Morgan Hall last spring. So they sent you a map with the old name? I'm surprised.
Well, this was actually mailed out months and months ago. I got a second packet in the mail more recently, with another one of these maps in it. I guess it must have the updated name. I left that one in my dorm room.
Well, things change fast around here. This building was renamed after one of our professors. She retired a few months ago. She's really well known in the world of physics. Too bad for Johnson, I guess.
Who was Johnson, anyway?
Oh, one of the early professors here. Unfortunately, I guess his ideas are going out of style. Science keeps marching forward.
I'll say it does. That's why I transferred to this university. I was really impressed with all the research equipment you guys have at the laboratories. You're really on the forefront.
So do you know what kind of engineering you want to specialize in?
Yeah, aerospace engineering.
Well, the aerospace engineering department here is excellent. Do you know that this university was the first one in the country to offer a program in aerospace engineering?
Yeah, I know. And a couple students who graduated from here became astronauts and orbited the Earth.
Right. The department has many prominent alumni. Well, you might end up taking some of your advanced math courses with me. I get a lot of the students from the engineering department because I teach the required applied mathematics courses.
Oh, cool. Actually, I want to get a minor in math.
Excellent. A major in aerospace engineering with a minor in math. You'll go far with that degree. More of our students should do that. There's so many more opportunities available in the field when you have a strong math background.
I'm glad to hear you say that.
Why does the man need the professor's help? What is the cause of the man's problem? Why was the building given a new name? What is the man's attitude toward his new university? What does the professor imply about aerospace engineering students? Listen to part of a lecture in a history of science class.
Okay, we've been talking about how throughout history it was often difficult for people to give up ideas which had long been taken for granted as scientific truths, even if those ideas were false. In astronomy, for example, the distinction between the solar system and the universe wasn't clear until modern times. The ancient Greeks believed that what we call the solar system was in fact the entire universe, and that the universe was geocentric. Geocentric means Earth-centered, so the geocentric view holds that the sun, the planets, and the stars all revolve around the Earth, which is stationary. Of course, we now know that the planets, including Earth, revolve around the sun, and that the solar system is only a tiny part of the universe. So, why did the ancient Greeks believe that the Earth was the center of the universe? Well, it made sense to them. Observations of the sky made it appear as if the sun, the moon, and the stars all revolved around the Earth every day, while the Earth itself stayed in one place. And this view is also supported by their philosophical and religious beliefs about the origin and structure of the universe. It was presented in the works of well-known Greek philosophers as early as the 4th century BCE, and the geocentric theory continued to prevail in Western thought for almost 2,000 years, until the 17th century. Now, what's especially interesting is that when astronomical observations were made that seemed to be inconsistent with the geocentric view, the ancient Greeks did not really consider alternate theories. It was so intuitive, so sensible that the Earth was the center of the universe, that astronomers found ways to explain those seemingly inconsistent phenomena within the geocentric view. For example, Greek astronomers made excellent, very accurate observations of the movements of the planets. But the observations revealed a bit of a problem. The geocentric theory said that the planets would move around Earth in one direction. However, astronomers noticed that at times several planets seemed to stop moving in one direction and start moving backward in their orbits around the Earth. And they came up with a theory that these planets themselves moved in smaller circles called epicycles as they traveled around the Earth. Here's a picture of what they imagined. You see how this epicycle theory could account for the seeming backward motion of a planet. Of course, today we know that this appearance of backward motion is caused by the fact that Earth, as well as other planets, all move in their own orbits around the Sun, and the relative movements of the planets with respect to each other can get quite complex. However, there were a few astronomers in Greece and other places who didn't agree with the geocentric view. For example, a Greek astronomer who lived in the 3rd century BCE. He proposed the theory that our planetary system might be heliocentric. His name was Aristarchus. Heliocentric means sun-centered, that the Earth revolves around the Sun. Aristarchus recognized from his calculations that the Sun was much larger than the Earth and other planets. It was probably this discovery that led him to conclude that the universe is heliocentric. I mean, isn't it more sensible to think that a smaller heavenly body would orbit a larger one rather than the opposite? However, his proposition was rejected, largely based on other scientific beliefs held at the time, which all made sense in a way, even if they were incorrect. Let me mention 2 objections Greeks made to Aristarchus's theory. First, they believed that everything that moves creates its own wind, so to speak. Everyone has this experience when you're running, right? So they thought that if the Earth itself was moving, there would have to be a constant wind blowing, sweeping them off their feet. And of course there wasn't. And second, the idea of an Earth that moved didn't fit in with the ancient Greeks' understanding of gravity. They thought that gravity was basically a natural tendency of all things to move towards the center of the universe, which was the Earth, or the center of the Earth. So that explained why apples and other falling objects were falling straight down. If the Sun was at the center of the universe, things would fall toward the Sun and away from the Earth, which of course they didn't. So these were some of the reasons they rejected the heliocentric theory.
What is the purpose of the lecture? Why did the ancient Greeks hold a geocentric view of the universe?
Why does the professor point out that Greek astronomers tried to explain new astronomical discoveries within the geocentric concept?
Why does the professor discuss the epicycle theory? In the professor's view, what might have caused Aristarchus to propose the heliocentric theory? What were two arguments ancient Greeks used to reject the heliocentric model? Listen to part of a lecture in a computer science class. The professor is discussing software engineering.
We've been talking about the software development cycle, and today I'd like to move on to the next stage of that cycle, testing, and why finding bugs during testing is actually a great thing. The quality of a software product often relies heavily on how well it's been tested. Liz?
Just a quick thing. Bugs is the word for problems in the program code, correct?
Yeah, in code or in a computer itself. There's a bit of a story behind that term. Back in the 1940s, when the computer industry was just starting, a group of computer scientists was working late one night, and there was a problem in one of the computer's circuits. When they examined it, they found a 5-centimeter long moth caught in there. Once they debugged the computer, it worked just fine. And ever since then, all kinds of computer problems have been known as bugs. Anyway, you want to find bugs while the software is still in the development and testing phases. Finding them when the software product has already been put on the market can be quite embarrassing. And generally speaking, every software development project has a group of testers and a group of developers. Jake?
And they're different people?
They're generally completely different groups of people. My personal opinion is that they have to be different groups of people because developers often have a bias toward their own work, and it blinds them to certain problems that might be obvious to somebody else. So it's always good to have a different set of eyes go in there and make sure that everything's tested properly. Okay, now here's the key. Developers and testers have different mentalities. The mentality of the software developer is constructive, creative. They're spending long hours working together to create and build something new. A software tester, on the other hand, their entire goal is to look at this product and find problems with it, to improve it. Now, this difference between the testers and the developers can lead to an environment where there's a bit of friction, and that friction sometimes makes it difficult for the two teams to work together. There were two projects that I worked on a couple of years ago. One, which I'll call Project Split, where the testing and development teams did not work well together, and the other I'll call Project Unity, during which both teams worked very well together. Now, during Project Split, we had defect meetings where the developers and the testers met together to discuss various problems and how they should be fixed. And you could sense the conflict just by walking into the room. Literally, the testers and the developers sat on opposite sides of the table. And the developers were very defensive about the feedback.
Well, if bugs are being pointed out, they wouldn't be too happy since it's their work.
Exactly. Now, because the two teams weren't working well together, the fixes were coming very, very slowly. And, you know, a lot of times when you fix bugs, you introduce new bugs, or you discover bugs in other areas that only come to light because something's been changed. So fixing all those new additional bugs was also being delayed. The test process went on much longer than expected, and we ended up having to put the product on the market with known bugs in it, which was obviously not ideal.
Okay, and what about Project Unity? How was it different?
This was different because the two teams worked closely together. During the defect meetings, instead of putting up walls, we didn't even talk about, who should fix this, who was at fault. We all acknowledged what needed to be fixed. So if we had 10 bugs, we said, hey, you know what? Let's do this one first because this will expose another whole bunch of defects that we haven't even seen yet. So we were being proactive and effective. And because we were so much more effective with our time, we were actually able to do more than just fix bugs. We even put in some improvements that we hadn't planned.
What is the main purpose of the lecture? According to the professor, where does the term bug used for computer problems come from? What points does the professor make about software developers? What factor made work on Project Unity efficient? How did the software product developed during Project Split differ from the product developed during Project Unity? When the professor discusses some work meetings attended by two teams, why does he say this?
Literally, the testers and the developers sat on opposite sides of the table.
Listen to a conversation between a student and her public relations professor.
Hi, Professor Gordon. I really learned a lot from your lecture, the one about analyzing all those different segments of the population. Oh, the official term's audience, right? I never imagined that one company could have over 30 audiences to communicate with.
Yeah, a lot of students are taken aback by this, and some public relations consultants don't figure it out till they've worked in the field a while.
Everyone thinks public relations, PR's easy, but there's a lot to it. You really got to know what you're doing.
Absolutely. So, Stacy, your email implied that you needed my advice about graduate school?
No, since my undergraduate degree will be in public relations, I've already decided to get a master's degree in marketing. Sorry I wasn't clear. My issue is I've got 2 required courses and 2 electives. I'm trying to figure out which elective courses to take. My advisor suggested economics and accounting, but I'm not really sure.
About?
Well, I endured accounting and economics in high school. I barely stayed awake. They were so...
Okay, I hear you. You say you wanted a master's in marketing. You've got 1 more semester till graduation. Have you taken any marketing courses yet?
No, I figured I've got the marketing basics already since I've taken every PR and communications course offered here.
Well, there's some overlap between PR and marketing, but there are important differences too. Marketing focuses on selling your product or service, attracting customers through advertising, and also building relationships with customers. That's what a marketing department does. PR is all about, it involves relationships too. That's why I'm saying the 2 fields overlap. But in PR, you're developing relationships with a wider range of audiences.
Right, like employees, suppliers, the media. I do understand this in theory, but aren't you still selling your product, just in a different way?
Not necessarily. Okay, do you remember that PR strategy I alluded to the other day? The one our university uses, a strategy that doesn't overlap with its marketing strategy?
You mean how the university invites local residents to attend certain lectures and classes for free?
Yeah. This cultivates a sense of goodwill and helps the university avoid becoming isolated from the larger community. Bringing neighbors into our classrooms is good PR, but it's not marketing, since our neighbors aren't our customers for the most part.
That's why I want to focus on marketing in graduate school. Wouldn't having expertise in PR and marketing give me more career options?
Yeah, but you'll also want to enjoy your work. So for your electives, why don't you take advertising principles and intro to marketing, which I teach? This way, you'd find out if marketing's something you really want to pursue. Graduate school tuition's expensive, and these courses will give you a good overview of the field before committing yourself.
I wish my advisor had suggested those courses.
Well, I'm someone who's worked in both marketing and PR, so I can offer a different perspective than someone who only teaches.
Why does the woman go to see the professor? According to the professor, what aspect of public relations tends to surprise students? According to the speakers, How does the university try to create a relationship with the surrounding community? What does the professor imply when he mentions that graduate school is expensive? Listen again to part of the conversation, then answer the question.
Well, I endured accounting and economics in high school. I barely stayed awake. They were so...
Okay, I hear you.
Why does the professor say this?
Okay, I hear you.
Listen to part of a lecture in a biology class.
Probably back in some previous biology course, you learned that snakes evolved from lizards, and that the first snakes weren't venomous. And then along came more advanced snakes, the venomous snakes. Okay, venomous snakes are the ones that secrete poisonous substances or venom, like the snakes of the viper family or cobras. Then there's non-venomous snakes like constrictors and pythons. Another family of snakes, the colubrids, don't really fit neatly into either category, though. Colubrids, and you probably learned this too, although they're often classified with venomous snakes, they're actually generally non-venomous. They're classified with venomous snakes because they resemble them, their advanced features, more than the other non-venomous snakes. Now, what if I told you that there's a good chance that most everything I just said is wrong? Well, everything except the part about snakes evolving from lizards. See, the basic theory about snake evolution has been challenged by a recent study that revealed a whole new understanding of evolutionary relationships for reptiles. You know, which reptiles descended from which ancestors. The researchers studied the proteins in the venom genes of various species of colubrids. Snake venom is a mixture of proteins, some toxic, poisonous, and some not. By analyzing the DNA, the genetic material of the proteins, the researchers could focus on the toxic genes and use them to trace the evolution of snake venom, and from this, the evolution of snakes. Traditionally, to understand evolutionary relationships, we looked at various easily observed physical characteristics of animals, their skeleton, the size of their brain, and then classified them based on similarities and differences. The problem with this method is that characteristics that appear similar may actually have developed in quite different ways. For example, some venoms are chemical-based, and others are bacteria-based. So they clearly had to have developed along different routes and may not be as closely related as we thought. Now, and not everyone will agree about this, but classification based on DNA seems to be much more reliable. Okay, back to the research. the researchers found that venom evolved before snakes even existed, about 100 million years before. Now, a couple of venomous lizards were included in this study, and the researchers found some of the same DNA in their venom as in the snake's venom. This suggested that the common ancestor of all snakes was actually a venomous lizard, which means that, actually, according to this research anyway, in terms of the snake's ancestry, there's no such thing as a non-venomous snake, not even colubrids. What separates colubrids from other snakes we've been classifying as venomous is not the lack of venom, but the lack of an effective way to deliver the venom into its prey. In most venomous snakes, like vipers and cobras, the venom is used to catch and immobilize the prey. But in colubrids, venom drips onto the prey only after the prey is in the snake's mouth. So for colubrids, the venom must serve some other purpose, maybe linked to digesting prey. As the different families of venomous snakes evolved, the teeth moved forward, becoming larger, and the venom became stronger. So the evolution of the obvious venomous snakes, like cobras and vipers, is about the evolution of an efficient delivery system, not so much the evolution of the venom itself. So if there are no truly non-venomous snakes, were the so-called non-venomous snakes, like constrictors and pythons, were they venomous at some point in their evolution? Well, that's not clear at this point. Constrictors have evolved to kill their prey by crushing. But perhaps they once were venomous, and then at some point their venom-producing apparatus wasn't needed anymore, so it gradually disappeared. There's one species of snake, the brown tree snake, that uses both constriction and venom, depending on its prey. So, well, it is possible. So, we have this new concept of snakes' evolution and a new DNA database, all this information on the genetic makeup of snake venom. And what we've learned from this has led researchers to believe that venom proteins may have some exciting applications in the field of medical research. You see, venom alters biological functions in the same way certain drugs do. And the big benefit of drugs made from snake venom would be that they target only certain cells. So maybe that'd create fewer side effects. Now, it sounds far-fetched. Venom as the basis for human drugs. So far, only one protein has been targeted for study as a potential drug. But who knows? Maybe someday.
What is the lecture mainly about? Why does the professor review information about the classification of snakes that students probably learned in previous courses? According to the professor, what is a major weakness of the classification system that is based on animals' physical characteristics? According to the professor, in what way do colubrid snakes differ from other venomous snakes? Why does the professor mention the brown tree snake? What is the professor's attitude toward the results from medical research on snake venom proteins? Number 1. In this question, you will be asked to give your opinion about a familiar topic. After you hear the question, you will have 15 seconds to prepare your response and 45 seconds to speak. Do you agree or disagree with the following statement? One of the best ways to learn is by making mistakes. Use specific examples and details to support your opinion.
Begin to prepare your response after the beep. Begin speaking after the beep.
Number 2. In this question, you will read a short passage about a campus situation and then listen to a talk on the same topic. You will then answer a question using information from both the reading passage and the talk. After the question, you will have 30 seconds to prepare your response and 60 seconds to speak. A student has written a letter to the university newspaper. You have 50 seconds to read the letter. Begin reading now. Now listen to two students discussing the letter.
Did you see this letter, Jim?
Yeah.
Be kind of nice to be able to do that, huh?
No, actually, I don't think it's a good idea.
Why not?
Well, like the part about how it'll help students concentrate. I mean, maybe a little snack will help the person who's eating it, but the trouble is that it makes it hard for everyone else to concentrate, because they have to listen to someone munching on chips, or biting into an apple, or crinkling paper wrappers.
I guess it can be kind of disruptive.
Yeah, it would interfere with everyone's concentration. You wouldn't be able to pay attention with all the noises going on.
Okay, I guess I have to agree with you on that. But what about her other reason? It would be nice to be able to have some fun at the end of the semester, right?
No, there's a problem with that too.
Why?
Well, I don't think it's appropriate to use class time for that kind of thing. I mean, the last classes are usually pretty important. That's when we do a lot of reviewing for final exams.
True.
If we use that time for that, we probably wouldn't have time to do as much reviewing, which means we wouldn't be as well prepared for exams.
Yeah, I hadn't thought of that.
The man expresses his opinion about the proposal in the newspaper. Briefly summarize the proposal, then state the man's opinion and explain the reasons he gives for holding that opinion.
Begin to prepare your response after the beep. Begin speaking after the beep.
Number 3. In this question, you will read a short passage on an academic subject and then listen to a talk on the same topic. You will then answer a question using information from both the reading passage and the talk. After the question, you will have 30 seconds to prepare your response and 60 seconds to speak. Read a passage from a psychology textbook. You have 50 seconds to read the passage. Begin reading now. Now listen to part of a lecture in a psychology class.
Okay, so this comes up a lot when people make career decisions. A friend of mine from college always wanted to be a film reviewer. He was a film major, and he loved movies. Most of all, he loved to write about movies. So when he graduated, he looked for a job as a film reviewer for a newspaper, because as a film reviewer, he'd get to see films for free and would be paid to write about them. That's what he loved. But he couldn't find a job as a film reviewer. So he took a position as a news reporter instead for a newspaper, investigating stories, writing about events, what news reporters do. Now, at first, my friend wasn't sure he'd be any good at this. He'd never been a news reporter before. But eventually, he adjusted and gained confidence, and he got used to the job. And he realized he was actually a pretty good reporter. Anyway, here's the thing. After a few years, the film reviewer for the newspaper where he worked quit, and my friend was offered her job. This was his dream, right? His opportunity to be a film reviewer had finally come, and the new job would actually pay more, too. But did he take the job? Nope, he turned it down. He told me he'd gotten used to being a news reporter, and he just didn't want to try something else. It seemed like too big of a change since, well, there was a chance that the new job might not work out.
Using the example from the lecture, explain the comfort zone bias.
Begin to prepare your response after the beep. Begin speaking after the beep.
Number 4. In this question, you will listen to a short lecture. You will then be asked to summarize important information from the lecture. After you hear the question, you will have 20 seconds to prepare your response and 60 seconds to speak. Listen to part of a lecture in a marine biology class.
A lot of plants and animals live near the surface of the ocean, and that means there's a lot of food near the surface because there are lots of plants and animals to eat. But if you go down to the deepest parts of the ocean, it's cold and dark, and there's not a lot living down there, so food is very scarce. So organisms that live down at these great depths have developed special adaptations to help them survive in this environment where food is so hard to find. For example, many deep-sea organisms have body features that enable them to eat prey that are larger than themselves. A good example, there's a species of eel that has an enormous mouth and a large stomach that's capable of expanding. And these unusual features allow this eel to eat prey larger than itself. That's a big advantage, because if the eel eats something big, that's a lot of food, a lot of nutrition. So the eel can go for quite a while before it has to find food again. Another helpful adaptation in some deep-sea organisms is the ability to generate light. And some organisms use that light to help them capture food. For example, there's a kind of fish called the anglerfish, and on its head, this fish has a little structure that produces light, that glows in the dark. This little structure, this little light, is positioned close to the fish's mouth. Other fish are attracted to this light. They think it's something small they can eat, so they swim straight toward it, and that brings them close enough for the anglerfish to capture them and eat them.
Using the examples of the eel and the anglerfish, explain two types of adaptations that help animals survive in the deepest parts of the ocean.
Begin to prepare your response after the beep. Begin speaking after the beep.
This task, you will read a passage about an academic topic. A clock at the top of the screen will show how much time you have to read. You may take notes on the passage while you read. The passage will then be removed, and you will listen to a lecture about the same topic. While you listen, you may also take notes. You will be able to see the reading passage again when it is time for you to write. You may use your notes to help you answer the question. You will then have to write a response to a question that asks you about the relationship between the lecture you heard and the reading passage. Try to answer the question as completely as possible using information from the reading passage and the lecture. The question does not ask you to express your personal opinion. Your response will be judged on the quality of your writing and on the completeness and accuracy of the content. Immediately after the reading time ends, the lecture will begin. So keep your headset on until the lecture is over. Now listen to part of a lecture on the topic you just read about.
Although companies are developing ships that can operate without a human crew, it seems unlikely that they will ever be completely autonomous. The arguments in the reading that support crewless ships are largely the result of misplaced optimism and ignorance about the capabilities of autonomous systems. First, costs. It's hardly fair to describe the crew as nothing more than a cost for the company. Although most ships already operate with the minimum number of crew members required, the crew are still very necessary to the proper operation of the ship. They maintain the ship by inspecting it for wear and damage, and they make repairs while they are sailing. On a crewless ship, those problems would remain unrepaired until the ship reached its destination, and leaving broken equipment unrepaired could cause a lot more damage. So having people on board the ship at all times can actually save the company money. Second, pirates. The measures mentioned in the reading would make the ships less attractive to low-tech pirates, but there are also high-tech pirates. Hackers can access the ship's data files to learn what it is carrying, and then compromise the autonomous systems like GPS to make the ship crash. Or they could take control of the guidance system and control the ship completely. That would allow them to send the ship to any location they choose. Then they could take their time removing the supposedly inaccessible cargo. Third, accidents at sea. The problem with container ships is not that their crew members react slowly, but that the ships take so long to change course. Container ships are among the largest ships in the world, and once they get moving in one direction, It is difficult to stop them or change their course. Sure, a computer could detect and react to emergencies like rocks or icebergs, but most of the other ships at sea are controlled by people, which makes them much less predictable. Computers only think logically, but human crew can anticipate the bad decisions other people might make and react accordingly.
Summarize the points made in the lecture, being sure to explain how they respond to the specific points made in the reading passage.